Ladies and gentlemen, please kindly take your seats. The conference will restart in 2 minutes. Ladies and gentlemen, if you would kindly take your seats, the conference will restart very soon. gentlemen, if you would kindly take your seats, the conference will start in very soon. Ladies and gentlemen, please take your seat. If you've done trying out our products, you can take your seat. The conference will restart in a minute. Ladies and gentlemen, we are really eager to introduce you to our new CBCT. So if you would like to take a seat now, we can start in any minute. Thank you. Ladies and gentlemen, our new product launch CBCT has already been live streaming online. So if you can take a seat right now, and our conference will start very soon. Thank you. Ladies and gentlemen, I guarantee you, you have more time to experience our products later. If you can take a seat now, our conference will start very soon. Thank you. Thank you, ladies and gentlemen. If you can take a seat now, our conference will start now. Would you please take a seat? Thank you. Welcome back, ladies and gentlemen. Welcome back. And hello to those who's watching us on live streaming. Ladies and gentlemen, we're also live streaming on both YouTube and Facebook and Instagram. So if you can kindly share the link of our live streaming, we will really appreciate that. Thank you. Okay, let's start this session. We move on to new product launch. Eighteeth has been dedicated to empower doctors and clinics with better equipment to improve the medical services and deliver better experiences for patients. To achieve this goal, CBCT has become an indispensable tool in dental practices worldwide. In this session, we would like to unveil our latest and groundbreaking product of CBCT. We have the privilege of hearing from CEO of Pheno Medical Technology, which is also the R&D center of CBCT. Mr. Peter is an expert who has dedicated years to the research and development of CBCT. Peter will share with us an in-depth introduction. Let's welcome Peter.
Okay. Okay, thank you guys, and welcome here to Eighteeth. Yeah, like this one is a presentation of the new CBCT. Some of you guys have seen this before, right? So I have some of the things here is haven't ever been seen before, haven't been opened before. Okay, so let's move to the presentation. Okay, and my name is Peter. Yeah, the Pheno is a part of Eighteeth, and we are focused on the X-ray image device. Yeah, and I was everyone knows Lalapix, right? So I was the software writer of Lalapix, and from here, recently I didn't write software anymore because we have much more genius guys for the software. So you can see from the CBCT, the software is much better than Lalapix. And we will still improve the Lalapix using our new technology. Okay, for this presentation, the first thing is the product philosophy. That's how we design this one. And the second one is the product. We named them as F350. Okay, and the third one is the image quality. That was some image coming from our customers. And the first one is face scan, face 3D viewer. That's the software we new developed to the CBCT. And the fifth one is the ThinCloud and the ThinWeb viewer. This is the latest version of our web solution of the image, especially in 3D. Okay, and the sixth one is the FaceSense. We never showed this one before. Yeah, this is for our service. It's a cloud solution for the service. Okay, let's move to the first one, our product philosophy. So for this one, is how we define this project. We started this project like 3 years ago. Some of our friends asked me at the beginning of this year. He said, "Why the Lalapix level upgrades after 1.8 version, right?" So here is the reason. Yeah, here is the reason. Because all our teams are focused on the CBCT project. Okay. So this is how we define the Eighteeth first CBCT. And also it's my own opinion how to make a good one. Yeah, a good machine with good price. Yeah. And here I was the responsible for the management of all the CBCT team, but also I act as an assistant designer. So I worked with our engineers for doing this CBCT. When I started my career at about 18 years ago, after I got my master's degree, I joined a company, medical company, and I participating in a medical CE project. At that time, one of my boss, he was used to be a chief scientist of GE Global Research. Yeah, and he teach me a lot how to do with the X-ray system. That's my first time facing with the X-ray. Yeah, and that was one word of him I remember all the way. Is that he said all of the technology improvement, what we do is to make the good image with lower dose. That's all our image system with X-ray we need to do. Yeah. So here we have two hands. On the left side, we have the effective dose is to the patient. It's to the patient, right? So the X-ray dose is to the patient is depending on the KV, MA, and the exposure time. And on the right hand, we have the image quality. We need the image quality to be good enough for the dentist. And the detector resolution, the two focus spot, and the system design and the algorithm, all of them are important for the image quality. So what we do is to make a balance. Why we do that? Maybe because almost all of the manufacturers in the worldwide, they can't do all of the things, all of the hardware in the CBCT. Yeah. So sometimes we need the detector to be better, but we don't have the capability to make a detector. So we buy from another supplier. So that's a balance. We need the detector to be used good. Okay. So this is the picture for us to do with that. That's the most important concept of this product. We need to make a balance. Okay. So what do we do to make the balance? For the first one, we make a short geometry system design. Oh, the system design is really important. Yeah. For this system, we have a little short with the geometry, and then there was a physical principle like this. The X-ray will rapidly drop down according to the distance to the source. Yeah, that's the physical principle. So if we make the geometry shorter than other competitors, we can use lower dose to the patient. So first one, the higher efficiency of the X-ray utilizing. Yeah, and another one, we have some issues to do with the system design is that we have a focus support that 0.5 millimeters. This kind of focus support is the best right now in the world. Yeah, and another one, we have a piece size of the detector is 0.1 millimeter, is also the best. So we need to matching these two together to make a good quality. So this balance is to make the geometry system short for better matching this kind of things. Okay, and the third one is for suitable for all of type of medium size of a flat panel. The flat panel is really important for the CBCT. And we have this detector here buying from our suppliers. So for this design, we can suitable for all of other medium size flat panel for this system. And the last one is the small rotate ratios make the machine smaller and more compact. Yeah. So this is what we did first for the geometry system design, doing the balance. Yeah. So with this geometry, we have a field of view at 16 by 10. Yeah, 16 by 10 is like a diameter of the patient, and the 10 is the height. So for this size, is the best medium field of view. The 16 is easily cover the TMJ for the dentist, and the 10 is easily to do the full mouth implant. Yeah. So 16 by 10 is what we do for the good use for the dentist. And another one we do make the balance is to make a line second scan. That's we call the fast scan with the system. We use some algorithm to make the line seconds better. We lower noise for the line seconds. So the algorithm here is ensure to high quality CT image with the fast scan. And with line seconds, we have half dose. And also this one is especially designed for children because children are always moving. So line seconds will make the moving artifact better when we scan with children. Yeah. So you can see from the image, the line second scanning with half dose, the image quality is still good enough. Yeah. And then we have the third one to balance the system is a post mode. It's a post mode to exposure to the patient. And the post scan technology also lower the dose. It will be less than 1/3 of the dose than the high resolution mode. Yeah. We have the resolution also make the image quality good enough. And the last one, we call them as AI-based Deloitte. All of you knows that when we use a KV and MA very low, that's the image quality will have more noise inside. So that will be not good for the diagnosis. So now we have an AI-based device to dealing with such of things. We make the lower dose image similar with the higher dose. So this is we do for the balance. You can see from the image that we before the deloys, you can see from here so many noise here, and we can smooth the image with the AI-based deloys technology. Okay, so this is the first part. That's we make the CBCT. Yeah. So this is the first one, and based on that, we will develop all of the other type of the CBCT with the different FOV, different resolution, something like that. So let's move to the second part. So with this philosophy, we make a machine like this, named F350. So this part is what's inside, and the specification of this product. Okay, here is the appearance. All of you have seen this one in the factory, right? And I have 3 more things for you. The first one is a compact design. It's I think it's the like the top compact one with our competitors. The maximum footprint is only 2.3 square meters, and it's easy to have a place in the shared room. And the other one, and also you can have a small room for this machine. You can save some money with the shared room reconstruction. Yeah. And the second one is a simple design. We call this one like the family design of the color and the shape and something else. So you can see the color and something is similar with other product with 80s. Yeah. And it's simple and it's suitable for your deco, for the clinic deco. Yeah. And the third one is we use some good materials for the cover. Yeah, for the outer shell. And it's environmentally, and the livability is good enough. Okay, so this is the appearance of this machine. And this is the footprint. Yeah, you can see the size is more compact than other competitors. And one more thing I need to mention is that we have a maximum height at approximately 2.3 meters. Sometimes the clinic didn't have that weight of the room, so we can have a limiting with these things. We have designed that. Okay, then it's easy for installation. We just have one package for the shipment, and then we have 2 parts of the machine with the staff and the main part of the machine. So after you install this machine, you didn't need any wall or floor mountings. It's just put it there. Yeah, just put it there. It's easy to installation. And if you want to move it to other place, it's easier. Yeah. And we have a 700 millimeters lifting stroke. That's suitable for children to a patient to an adult, which is like 1.9 meters height. It can scan with the standing, with the patient standing. Yeah. And another one is the wall and the floor mounting accessories we can supply to the customers. And we only supply this in the earthquake prone areas to make a safety use. Yeah. And this is the key component with this machine. The first one is the CBCT and the panel detector. We have an IG0 detector here for lighting 8 micrometers, and it has some of the parameters much better than other competitors. So this is important. They have a free ROI and a 16-bit ADC. It's good for the image quality. And another one for the Cephalon, we have also have IG0. Actually, we have two choice for this kind of for F360, 350. Okay, so this is also IG0 TFT. Yeah, it's like 100 micrometers, and the resolution is good enough for the Cephalon. Okay, here is the tube. Nowadays, we just have two choice of the tube. One is from Toshiba and another from CEI. And some Chinese manufacturers also have the tube. But in our product, in this product, we just have the Toshiba tube. And Toshiba sold all their medical business to Cullen, so also called Cullen tube. It's a small tube in the CBCT, and the reliability of this tube is better. Okay, and for this CBCT, we just have a CT image and panoramic image, and then cephalo image. This is a panorama image. We have a multiple pen technology for autofocusing to the frontis. So it's slicing. We have several slices during the panoramic scan. And this is for the multi mode for the cephalo. And it's lateral, frontal, and the carpus are all supported in the cephalo mode. And this is specification of this product. And the first one is a cone beam. It's a cone beam. It's a cone beam, and we can use with continuous and pulse mode. And another one is the tube voltage is from 16 to 100 kilovolt. Is that suitable for all of the patients? And the focus voltage is 0.5 millimeters. And we have focus size from 0.1 millimeter to 0.3 millimeter. And for the detector type, we have two choices. One is for the amorphy silicon, and another one is for IGZO. And the cephalo is also, one is CMOS, and another one is IGZO. And the gray scale is all of the detectors. Gray scale is 16 bits. And the scan time for the CT, we have two modes. One is for 18 seconds, is for normally scan. And another one for 9 seconds for the fast scan and for the children's scan. And the panorama, we have an arch scan at 14 seconds, and with a TMJ at 6 seconds. And for the cephalo, we have a lateral with 8 seconds, and the frontal with 6 seconds. And the reconstruction time right now is really fast than our competitors. It's less than 16 seconds. But with our configuration of the computer, we can reconstruct at 40 seconds. And the patient position is like standing. And the patient alignment, we have 4 laser for the patient alignment. And the control device is like we use some of the touch panel to do the decorating of the machine. And the PC is with the face scan software to the customer. And the dimension is like this. And the weight is like 220 kilograms. Another workstation is like a memory like 16 gigabyte, and the field of view is 16 by 10. So this is like a specification of this product. Okay, let's move to the third part. It's like the image quality from our customer side, because as you know, this is the first product we launch in China first, then the overseas. So we have some experience in China. It can really help the customers overseas. Yeah. So this is image quality is coming from our Chinese customers. Right now we already have the CFDA approval, and we have almost like 200 customers right now. So we have some experience with this. So image show for customer side is like this. So this is like a CT image. Case 1 is a good test. You can see the resolution for this kind of detector is good enough. And the bad test like this is also, you can see I think the resolution of this screen is not that good. Okay, so sometimes you can find the computer to see the resolution. And the third one is a single implant. This one is made with pulse mode. It's pulse mode with the implant. You can see that the artifact is good. There's a rarely artifact inside. Yeah. So another one is for multiple implant. This is the tough situation with the mental artifact reduction. And this is for multiple crowns. All these kind of things are really tough things for the technical guys to make the image better, because there was some physical principles inside. The X-ray will be scattered during the implant or during the crown. And then we have a filler under the crown here. This is the most tough one. Yeah. So the filler is also high density. So high density will make the image really bad. So we have some reduction technology to make it not influence the diagnosis. Okay. The next case is also implant and crowns. Sometimes we need to do a scan after the crown was established, and then we can make a CBCT scan. Sometimes it was not good beside this one, but for image, I think the algorithm for the artifact reduction is good enough. And then this is the panorama image with wisdom teeth. And you can see that the panorama image is hard with the front teeth. Front teeth is the most difficult thing. And we can see from this image, front teeth is good enough. And also another case is similar. It's also have a good image quality with the front teeth. And the third one is have an implant inside. And here is the things for the some need clothes. Yeah. And we have a 4 bracket here. It's also a tough thing for the panorama scan. Okay, here is the cephalo image case. Yeah, the cephalo is simple. It's simple. And we just make it this one like the image good enough for the diagnosis and for the cephalometric. Okay, so this 2 cases, the second case and the third case, all of these images, we can use the AI solution to do the cephalometric. Okay, let's go to the first part is FinScan and Fin3D viewer. And this is a new design software, as I told, because right now we have over 50 employees in Fino for the X-ray imaging development, and half of them are development guys, development engineers. So right now we have over 12 software engineers. So it made the FinScan and the Fin3D with a new method and a new technology. So it's a new design software. And we make this software easy to use. First one, this is similar with Lalpix, right? So we make it as a workflow design. It's from the patient registration to the scanning and to the image viewer and then to the report. So this is for the patient management and the image management. It's a new design and it's suitable for all of the computer. Like a lot of some compatible things issues with the Lalpix, but with this one there was no competitive things issues. Yeah. Okay, so this is for the. Okay, so this is patient management. Oh, it's switching. Yeah, it's switching. And the second one is for the scan control, and we can choose a mode, and then we choose the parameters for scan, and then we choose the field of view and do the scan with a schedule, and then we get the image. We get a projection image here. Okay, so this is for the viewer. This is definitely for the 2D viewer, like a Lalpix, a 2D viewer. We have so many tools for the 2D viewers, and it's similar with Lalpix. It's similar with Lalpix. So any client they have any dentist they use Lalpix before, they will be easily to access to this software. Yeah. And we can view the 2D image like panorama and cephalon here. Maybe furthermore, we will make the LALPIX inside this one. And this is a report. It's a new design report, much better than LALPIX. Yeah. And here the report, we can define the template right now. We can define the template and we can make some box and do some things and make some recommend inside. Okay, and then move to the Phase 3D viewer. Here is the Phase 3D. We designed this one by ourselves from the very beginning. Some of the competitors, they buy a software from third-party suppliers, but we developed this one by ourselves. So this is a 3D viewer, and we have several functions with the 3D viewer. The first one is the multiple plan reconstruction of this view. It's a multiple, and we have a traditional multiple plan reconstruction. And for the 3D side, we have several like rendering choice for the users. Okay, so this is the CPR. It's a curve plan reconstruction. We make the best curve plan reconstruction in this software. It's very easy to use. You can just move the, okay, let's move the cross to any place you want. You didn't need the 3D dimension impression in your hand. You just move the cross line to any place you want, and it will show the 3 dimensions to you. It's very easy to use for the dentist. And next one is the love canal. We can draw the love canal from this view, and for the implant. And also the measurement for the implant. Before we choose a implant, we have a measurement with the bone, and then we make the measurement, and we have a value beside the line. Okay, then that is a bone density analysis. We have a area bone analysis to make the users to know which bone is enough for the implant or not. We have some colors for this. Yeah, some colors for the different type of bones. So this is the bone density analysis. And another one is for implant database. Right now we just have like 10 brands of implant in our database, and we will upgrade it all the time. And this is a choice. You can see from here. We place an implant, and then we choose a location of the teeth, and then it will automatically put the implant to the area. And we just need to move it, adjust it a little bit. Okay, so this is the implant database. We also have an online implant database to upgrade to the customers. And this one is for the implant simulation. It's easy to find the right place for the implant. And then we can use this views to find the distance with the nerve to the implant. And we can automatically calculate the distance for the users. Okay. So because our field of view is like 16 by 10, so many of the patients can have a TMJ in one scan. We can have the TMJ here. So TMJ is like some orthodontic, they need the TMJ diagnosis. So we have a TMJ view for the orthodontics. So this is all the image. So all the software is new design, especially the 3D software, because we didn't have the 3D software when we developed the LALPIX. Okay, and the software we can have online upgrading, and we will upgrade it all the time. Yeah. And the first one is the ThinkCloud and the ThinkWeb Viewer. So this is a new cloud solution for the remote diagnosis. Some of the guys ask us for send a demo image or send a software to you, but it's big, right? It's big. It's hard to transportation. But with this cloud, you can easily transport the transportation, the image to your customers, and you can just send a website to him, and he can see the image from the website. It's easy for you to contact with your customers. Okay, so ThinkCloud and ThinkWeb Viewer. The first of all, we have a 80s dental digital cloud platform. This is especially designed for the CBCT. And in the intraoral scanner, we have another one. But we will have the same entry in the website. And you can choose different product into different cloud platform. So this is the cloud platform for the CBCT. And you can have your patient's information here. You upgrade the image to the cloud, and then you can see the image here. And this is patient management in the cloud. And then this is the institution's management. You can have your colleagues inside of this cloud. And the colleagues can also see the image you update. You upload the image, and your colleagues also can see the image. And then the web viewer. We have 2D web viewer for Panorama here. And we also have an AI solution for this Panorama. Yeah, you can choose the Panorama image you have. You upload, and then open the image here. And then you can use an AI solution. Right now, the AI solution is just like a Chinese version. And we are upgrading this one with the English version. So this is the Chinese version. It's similar with the Lalopix AI, but more information is inside. Yeah, we can recognize all of the things here for the dentist, and we can output a report. This is a report to the customer, and the customer can scan a code to download the report. So this is for Panorama. And also we have a 2D web viewer for the Cephalo. Just we view the image here. And then we have a cephalometric AI here. It's automatically draw all of the points for the dentist. And it also have a report to the dentist. And right now it's also Chinese version because we launched first in China, and we will have an English version maybe in the end of this year. And another one is for the 3D viewer. So this is a totally new thing. We make like you see here, it's a website, right? It's a website. You use some web browsers to open the image. And the user interface is totally the same with the Fin3D viewer. So the users can't need to learn some more operators with this 3D. It's totally the same with the PC software. Okay, so this is a 3D view, and the image quality also the same with you see in the PC. And this is 3D web viewer for the CPR. So for the curve plan reconstruction, it's also the same. So for the dentist, you didn't need to learn more about the software. Just need to learn one software, and you can use the web viewer rapidly. And this is the implant. It's also the same with the Fin3D viewer. And this is supported by all the web browsers like Google, like Firefox, like Edge or something. Okay, and the last part is for the FinSys. Why we call this one FinSys? It's like a cloud platform for service workflow. Yeah. So since it's like IoT IoT concept. We make all of the machines connecting together. We call this one like FinSys. It's cloud platform for service workflow. So how we can do this? So this is the overview of FinSys. First of all, we do the fault warning for our partners. The fault warning. We have a center for inspection all of the machines we sold to worldwide, and the monitor of the operation status of the equipment in real time, and manufacturing the consumer parts based on user usage frequencies. Because sometimes it have some malfunctions with the machine, and we can find the malfunction from this side, and we can predict the faults in advance and trigger the alarms to our equipment from the equipment side. And then otherwise fault localization. Oh, this is important for our partners to do with the service. Yeah, it's a real-time recording to the equipment operation logs, which are compiled with the standard operating logs. And when we update this one, we can make it as this kind of things. Like the machine have some malfunctions, but the service guy is just on front of the clinic. It's just in front of the clinic. That will make the customers satisfied with the service. Because the CBCT is a big one, big one have several motion parts inside. So we need to make the service good enough to make it reliability, yeah. And another one is for the CRM support. It's the interface with our CRM system and automatically assign some work orders to the regional service engineers. So you will have engineers have training in our factory, right? So that engineer, we can put them in our system, and then we will send the message to them. Which machine have which kind of problems you need to bring something to the customers to fix what kind of things. Okay, things like this. So this is the overview for our FinSys. And this is the entry for the service, and you can have a client have an account here and entry to the service platform. And this is engineering management. We can have your engineers inside of our system and then cooperate with us. And this is work order management. We will have some work orders to your engineers. Right now, it's not the English version is not that good. And this one is for work orders execute. Yeah, the engineer will come to the customer side, do the service, right? So we can have some record for this kind of manufacturing, this kind of services inside of our system. And this is like a history, like a history. We can have some of the issues that the malfunction with the machine, and then we have so many experience inside of the system. And then product registration. And at the customer side, when they finish the installation, it will registration the product to our platform, and it will monitor the product after we do the registration. And we will have a service center here in China, and then we can share the account to our partners worldwide. And then we can make all of the machines here. You can see all the machines you sell in this system. So this is called a service center. And then we will have this kind of things. It's like a service center visualization. You will have a monitor to do with this. Have a monitor in your office and see all of the product that you sell and about the status of the machines. Okay, right now it's in China. In China, we have 69 machines inside of this. Most of them are not, because this is just launched last month. Yeah, we'll just continue improving that. Yeah, and we can see the online. Let me see. We can see the online machines and how many CT scans they do per day. Yeah, and then the offline machines and things like this. We have some report about the machines used. All of this kind of thing is worldwide. It's worldwide. We can share some account to our partners, and you can see your region's products. So this is totally new things. We just launched it last month in China. So we were upgrading this one continuously. Yeah. Okay, so finish the presentation. Okay. Thank you. So any questions you can have with this machine.
Thank you so much. First of all, it's an amazing, promising product.
Thank you.
I just have a question about, you mentioned the AI for the panorama and for the lateral ceph.
Yes.
When do you expect we can have the AI for the COM-beam?
For COM-beam CT, right?
Yes. Because, you know, it is the most hard thing for dentists to read a COM-beam CT.
Yes, that's right.
Some courses to learn how to read correctly.
We plan to launch that maybe in the second quarter of next year.
Okay.
Yeah, second quarter of next year.
It's really important, and it will help dentists to read correctly the
CBCT image, right?
Yes.
Yeah.
Yes.
We will launch it maybe in the middle of next year. Because it's some development things have already done, but it was not integrated into the system. Yeah, we have some segmentation with the CT image and have a report with the implant things or something else. But the technical things is done, but the integration is ongoing. Yeah, so maybe we will launch this one at maybe the second season of next year. Yeah, second quarter of next year. Yeah,
great.
Second quarter. Yeah.
What about the integration software between COM-beam CT and Helios?
Helios, right?
Yeah.
Oh, that will be
discuss with.
We have this plan. Yeah, Dr. Chen. Yeah. Because right now, because right now there was some technical things in the combination with the intraoral sensor and the CBCT image, right? First one, the resolution is not the same. First one, second one, the coordinate things is not the same. So we need to do some match things. The match thing right nowadays we can use some AI technology to do that. But we didn't discuss with Dr. Chen before. Maybe we will discuss that.
Yeah, diagnosis for the dentist. Say, I have the scan, I have the COM-beam CT for implant case.
Yeah.
Together is very useful for the dentist to diagnose, to operate, to everything.
Okay. We will plan to do that.
Yes. And last thing, I want you, you are an expert for COM-beam CT, just to mention and set points. What's the advantages we have over our competitors?
Over our competitors.
In
okay.
Points,
so I think the most three important things for CBCT is the first one is image quality. The second one is the software. And the third one is the service. So we need to make these three better than our competitors so that we can have a good product to our customers. And for this one, I think image quality, with our competitors using the same detector, I think our image quality is the best. It's the best. And for software, I think is the top level software. And for the surface, depending on all of you, and with this system, yeah, because it's CBCT totally not the same with the small product, you know. Small product, you just do the surface as replacing one, yeah. But for this one, you can't replace.
Thank you so much.
Yeah.
You mentioned about service. It's one of the most important part.
Yeah.
I know it's quite difficult to mention this service part
Yeah.
because you're the manufacturer. But
Yeah.
can you share with you what are the challenges? Is it physical machinery problem that it's quite challenging, or the software is a more of a challenging part?
The most challenging part, let me see, is the physical principle. It's physical principle. Like you see, like I said, I used to be an engineer with a medical city, you know, medical city. And the medical city is really much more complicated than this kind of CBCT. Yeah. And all of the top engineers, they focus on the physical things, because all of the tough things is from physical thing, you know. So, and for algorithm, we make the algorithm to solve some physical problems, and then the software. I think software may be the second challenge. Yeah, second challenge.
Thank you.
And mostly the AI solution. AI solution. Right now, the basic software is enough for all the dentists. I think is enough. But the AI solution, we need to continuously improving that.
When it's not a question, okay? When you mention AI,
Yeah.
Japanese government
Yeah.
thinks it's very difficult to grant certificates with something like
certificate. Yeah, that's right.
AI.
Yeah.
It's not a question, but please help us.
It's the same in China. The same in China. The same in Europe. You know, but AI solution, like I said, you need a certification for AI, right? Our Lalopix also, but AI is really difficult for registration side to get approval. But FDA, they need a approval. I think the regulatory is a little bit like later than the technical improvement. You know, the regulatory. But sometimes in FDA, I know that FDA, if you sold the product with the AI, that you must have this AI certification.
Sure. I think this could be the breakthrough for
for other competitors.
Yeah, exactly.
Yeah, that's
So
right. That's right.
if you
So
can
we are
work
planning to do that.
Yeah, if you
We are
can
planning
keep
to do that.
continue.
Yeah.
Thank you very much.
Yeah.
Peter, thank you for the great presentation, first of all.
Thank you.
Maybe I've missed it, but what about the implant database? How large is it, the implant database? And
right now,
and Peter, the second question is following.
Okay.
The procedure of adding new implant systems,
Implant,
is it
right?
hard?
Yeah. Okay. That's some kind of a history since, because we launched this project maybe in 2021. Yeah. And we have low, let me see. We can't find the implant companies to send their implant to us, right? So we draw the implant by ourselves. So the database, now you see the database is really tough things for us. Yeah. But depending on our we sold so many machines in the worldwide, and the implant companies will find us to make the implant inside of our software, So we're waiting for that. So waiting for you guys to sell some.
All right. So for example,
Yeah.
if we are promoting our own implant system, we can send you, the sizes of it.
Yeah, you can send me the size. Yeah.
No problems with a patent.
Yeah, I
No
don't.
problems will be.
Yeah, no problem.
Okay,
No,
that's great.
no problem with the pattern.
Thank you, Peter.
Yeah, if the machine is the amount of the machine is too big, the implant company will find us to send me the data.
All
But right now we didn't have that, capability to do that.
Right. Thank
So
you,
we
sir.
draw the implant by ourselves.
All right.
So it's really tough,
You're good
So,
drawers.
so right now we just have like 10 brands. 10 brands. And we can have a customized of the implant, but with a very cylinder or something like that. Yeah.
That's good. Thank you.
Yeah.
And any more questions? Any more questions, ladies and gentlemen?
Okay, we have a machine in our factory can scan the patient, the real patient. So if you guys have if you guys need to do a scan, you can go to our factory, and we have a shared room for one machine to scan.
Okay, we have one more question, Peter.
Thank you, Mr. Dick. Okay, my question is, in figures, how is the reduction in radiations?
Radiations, right? Reduction of radiations, right? Okay. So radiation is two parts. First part is directly to the patient, and the second part is the irradiations everywhere, right? So we have a collimator inside to make the surrounded irritation less. Yeah, have a collimator inside. And for the patient side, we just use the balance things to make a fast scan, to make a post scan, something like that, and then make a Deloitte things to do with the radiation to make the dose less than the high resolution mode. Yeah.
But how is on figures? How much is the reductions?
How many, right?
Yep.
How many? Like we see the radiation of this kind of a machine is depending on the distance from the source side to the detect side, right? For our machine for the CBCT is like 50 microgray, 50 to 60 microgray.
Yeah,
It's
because,
similar with other competitors with pulse mode.
my second question is that you can only take image by 16 times 10 at this moment.
Yeah,
Okay. How about the smaller FOV?
more effort, right?
Yeah.
Okay, that's my sense. Most of the manufacturers can't manufacturing a detector and the X-ray too. Yeah. So right now in the medical CT field, they have some new technology for reducing the dose for the patient with a new detector, new material of detector, new tube or something like that. But I think the dental field, I think maybe 10 years later than the medical CT side, because of the cost. You can use like a photon counting detector. Yeah, photon counting detector is now worldwide used in medical CT, but it's very, very expensive. Very, very expensive. But this kind of detector can make the dose much lower than right now.
Okay.
But the cost is really expensive for dentists. So maybe 10 years later, we can have a photon counting detector for CBCT.
So let's say if I only need to take quadrant 1, I
Yeah.
still have to take the whole skull.
Yeah.
I cannot just take one part of the.
One part, yeah. We can choose a separate area for you to scan.
Can we do that?
Yes, we can do that.
Okay.
We have a function here. We have a scout here. For your, we call this one like a region of interest scan, right?
Yep.
Region of interest scan. And we have two solutions for this one. One is we just scan this kind of, this field of view, and just to show this one, right? This is the first way. And another way, we just scan here. And we make the collimator much little than this one. But right now, in most of the competitors with this price, we don't use the collimator to adjust the windows. Yeah, the window is constant. Window is constant, so the dose is constant. Even you use a region of interest scan. Yeah, but we are making an adjustable collimator to do that.
Okay. Yeah, thank you.
Yeah, maybe in the later generation of product.
Okay, thank you.
Yeah. I have one more thing for your question. So it's for endo mode. Sometimes the dentist need an endo mode with a region of interest scan, right? But the resolution of nowadays, the detector's resolution is not good enough for endodontic, right? It's not good enough because it's 0.1 millimeters. 0.1 millimeters. For a lot of people, it's 12, is 20, right? 75 is a fake one. It's fake one. We can make a slice like whatever you want. We can make a slice like whatever you want. But the resolution is determined by the detector. You cannot make it lower than the detector, right? So maybe next time we will have a plan to do a machine, especially for the dentist, for the endodontic. We will have a much higher resolution of the detector and a very small focus mode X-ray tube to do that. But right now, no suppliers have such of things. We are cooperating with our suppliers to do this. Yeah. So maybe next year you can see this kind of machine. Yeah.
Hello. I have a question regarding warranty.
Yeah.
Since I don't know what the situation in the rest of the world, but for Vatek in Europe,
yeah,
there is a warranty on the machine for 5 years.
5 years.
And 10 years for sensor.
For sensor, yeah.
Do you consider any of those services for longer term of warranty, even if it would be like payable service?
Oh, that's.
Thank you.
That's like a sales questions. Yeah. Sales questions.
One question is quality of the product.
Yeah.
And business wise, always it's considered regarding not also quality,
yeah,
but also the warranty.
Product quality.
And warranty itself, it's also a good point when we talk about sales in general.
Yeah.
Thank you.
That's what we do here. With the technical things, we can we can monitor all of the machines outside. And then we have some data for the customer side, right? So we can determine the things to do with the warranty, you know. Because some customers use this one very frequently. Someone didn't use frequently. They scan 3 or 4 patients per day, right? That's different. But we don't know right now. Yes, we don't know right now. But with this system, we can know. So maybe we will have some like some policies, politics things to do this. Yeah, politics. So any sales guys to answer the questions for warranty?
So we give the official warranty of CBCT for 3 years. Yeah.
They told that Vatek with 5 years and warranty with the whole machine and 10 years for the detector. Yeah.
I think for this, we can discuss with the partners in different countries to see if we can make any extent. Yeah, as Peter has said, that this is good for our distributors to monitor, remote control the devices, the CBCT in all countries to know what is the problem, and we can fix it easily with the partners. Yeah, this is a very innovative functions. Yeah.
Here, ma.
Hello, Mr.
Hello?
Peter.
Yeah, hello.
So I have a question about the after-sales service.
After service, okay.
Yeah, about the spare parts, does it depend? Does the spare parts
Pay
depend?
the parts, right?
Yeah.
Okay,
The spare
that's
parts.
also sales questions. 维修备件的价格之类的。
No. The spare parts,
Spare part.
does it
Yeah,
depend
spare-
on such serial number?
Yes, 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 and we registration the product inside our platform. We using this of serious number.
So in this situation, we cannot have stock for the spare parts because it depending of each machine on the serial number. That's
Yeah.
right. Yeah,
对，可以拆的。Yeah, yeah, yeah. It's replaceable.
So it doesn't depend.
Maybe we can have some spare warehouse outside of.
Okay, thank you.
Okay. Okay. Thank you, guys. And if anyone of you have a requirement for the scan, you can go to the factory. We have a machine there for you to scan. Okay.
Thank you, Peter. Thank you. Thank you, Peter. Thank you very much for your introduction. I hope you got enough information that you need. And so this is all of today's speakers. And I want to thank you for your attention for today. And next, we'll have a short networking break. You can feel free to have more time with our products, try our products, and our engineers will be happy to answer your questions, just like the last tea break. But also, we have prepared a rooftop barbecue party with halal food and live band. So you can go to our 5th floor, to our rooftop at 5:40. 5:40, that's the time that we'll be ready for you. And enjoy a very lively day.